We're going to be looking at example 2a in your section 4.3 notes. Our goal is to find the intervals where the function is increasing and on which it is decreasing. We're once again going to use theorem 4.7. So we need to know when the first derivative is positive, greater than 0, or negative, less than 0. So the first step to do this is to find where the derivative is equal to 0. Okay, so the derivative here uses the power rule. So we end up with 4x cubed minus 12x squared plus 8x. Okay, we're going to set that equal to 0. I'm also going to pull out a 4x, the greatest common factor. So when I do that, I end up with an x squared minus 3x plus 2. Okay, this factors further. We can multiply to 2 and add up to negative 3. So we end up with x minus 2 and x minus 1. All right, so we get 3 critical points. So 0 from the first expression, then 2 and 1. All right, so next what we're going to do is we're going to do something called the sign test for the first derivative. Okay, so you can go ahead and make a number line. Okay, we know that the domain of the first derivative is all real numbers because it's a polynomial. Put the critical points on there. So we've got 0, and then 1, and then 2. Okay, and then we want to check the signs in the first derivative since we're looking for where the first derivative is greater than 0 and less than 0. One quick and easy way to do this is to use your graphing calculator. Okay, so I went ahead and entered the first derivative into my graphing calculator, 4x cubed minus the 12x squared plus 8x. And if you go to your table feature, you can look at the y side of the table. Apologize for the glare here. To see what's happening as far as positive and negative values go. Okay, so it's going to be pretty easy to see what's happening on the left side of 0. We get a negative 24. Okay, so for our sign test, we can say we'll have negative answers here. Okay, the way that I have my table set, I can't see what's happening between 0 and 1. I would have to set my features a little bit differently. Okay, but I can definitely see what's happening on this side of 2. So on this side of 2, I have 324, so I have a positive here. All right, so we don't have the middle two intervals at this stage. Okay, but it's not that hard to figure out the signs if you don't want to change your settings. So you would need a number like 1/2 in here. And then you can just look at your signs, right? So if we plugged in 1/2, we'd have a positive number. We plugged in 1/2, we'd have a negative number. And we plugged in 1/2, we'd have another negative number. Okay, so positive times a negative would end up being a positive sign. Okay, we could do the same thing for like 1.5, and we discover that would be a negative sign. Okay, so now we're ready for our conclusions. Everywhere we got a negative sign for us, that means we have decreasing intervals. And everywhere we got a positive sign for our function, we're going to have an increasing intervals. Okay, so our conclusion for this is f is decreasing on the intervals negative infinity to 0 and 1 to 2. Okay, and then f is increasing according to our sign test on the intervals 0 to 1 and 2 to infinity. And that completes example 2, part A.